Hello, ladies and gentlemen. It is your friendly neighborhood Mr. Rolls coming at you today on Friday. I know that we're expecting a lot of people to be absent today, so I thought that I would record today's lesson in a brief video for you to look at and take notes on when you've got the time. This past week or so, you might remember that we've been studying development and how countries, sort of at the national scale, how countries advance developmentally, economically. We've looked at a few theories to support that. We looked at Rostow's economic development theory, and I gave you the 5 stages in a graphic organizer that has 5 boxes that go from traditional societies to the age of mass consumption. We also looked at Wallerstein's world systems theory, and specifically the core periphery model that shows us how really the global economy is a interconnected whole. And what happens in one part of the world with their economy will, in fact, impact all other countries to some degree. We looked at core countries, peripheral countries, semi peripheral countries. We also talked about commodity dependence and dependency theory, um, also dealing with how countries relate to each other. Today, we're going to sort of reduce the scale of what we're looking at, and we're going to talk about the decision for building a factory. We're looking at that secondary economic activity, that second block there. About 25% of Americans are involved in the manufacturing sector. Um, as we've discussed, many of our factories have been outsourced, but still, there are plenty of factories and manufacturing sites in our country today. And so we're going to take a look at that today, and we're going to take a look at yet another model called Weber's least cost theory. So that's going to be coming up. All right, so go ahead and take some notes on this following part. This slide says that manufacturers must consider a number of factors when locating a production site. Creating factories is a long-term investment that cannot be easily relocated once built. So careful consideration of the following factors is a priority. And we're going to consider 5 of these factors. The first is energy. So manufacturers must obtain cheap, plentiful energy to continue their operations. All factories need to be powered from something. And you can imagine that most factories use an incredible amount of electricity. And that's going to be one of the major costs that manufacturers have to undertake. So they want to have access to plentiful, cheap electricity, whatever the source of that may be. All right, number 2, we're looking at materials. Every factory needs raw materials to construct finished goods. Today, most inputs, the things that factories need to make other things, have already been through some production process. So, for example, if you think about how an automobile is created, there's a lot of steps that go from taking ore out of the ground, processing it to steel, and then shipping that material to an automobile manufacturer. You're not simply going to refine that steel into steel and just dump it in the middle of a car factory, right? That steel is going to go through several steps of refinement and several other things to get it to the ability to where the car manufacturer can actually use it. So it requires a lot of steel that is ready to be stamped by these pretty sophisticated machines into the frames that are eventually going to form the body of that car. And so stampable steel has already been through a pretty complicated process to get to that point. So um, while everything originates from raw materials, those raw materials just don't go from raw materials to finished product in one factory. It's going to go through several different factories to get to that point. Okay. Next, labor. Often labor is the most significant factor in locating a manufacturing site. And companies are always incentivized to reduce their labor costs as much as possible and may relocate to peripheral regions to reduce their costs. So basically, they're going to take advantage of lower um, minimum wage laws that might be present in, say, China, India, Mexico. And also not just in between countries, but intra-regionally as well. So, for example, textile manufacturers largely moved in the early 20th century in the United States from the high-wage manufacturing areas in New England, where there was a lot of unionization that created higher wages. Many of those companies simply left and moved to the American South in Georgia and in South Carolina, and today, manufacturing in the United States is incentivized and is moving from the Northeast to the Southwest to take advantage of lower labor costs, lower unionization, and other factors as well. Okay. All right. Next, we have markets. So basically, think of a market as the place where you finally sell something and you make money, right? There isn't necessarily one location for a market. Sometimes there is. So, for example, a grocery store is a market, a auto dealership is a market, but there are plenty of markets out there that don't have one location. So we think of ordering something online from Amazon. Amazon is a market, and they deliver the product to you, and there isn't one physical location that you go to purchase that product. But anyways, those companies that need to transport finished goods, they want to be located close to a market. Okay. And they want to be located to that market to reduce transportation costs. Okay. If a company, is involved in a footloose industry, then its transportation costs are minimal and they can be located anywhere. A footloose industry is one where the final product does not weigh much. You can fit a lot of it into a truck. You can transport a lot of it in mass. Think of small, inexpensive jewelry. Think of paper clips, staples, little office supplies like that. The final product doesn't weigh a lot and can be moved anywhere. And I suppose you could consider, um, web-based markets to be footloose industries as well. IT work and that type of service. All right. Lastly, we have transportation. So, transportation is important. Transportation costs from the manufacturers of the market are extremely important. Large goods typically go through several break of bulk points where they are broken down into smaller vehicles. So, trains to ships to trucks to finally the market. So, you think of some kind of very large container of a particular product. Maybe it's coal, maybe it's rolled steel, maybe it's even just a train full of a particular agricultural product. Well, it's not particularly efficient for that train or that cargo ship. You could think of an oil tanker to go to a gas station, right? It needs to offload those goods into a smaller means of transportation. And then it may need to be broken down a couple more times until it gets to the smaller portion of transportation that takes that good to the market. Okay, so like you guys have maybe you've been to a gas station when one of the fuel trucks is there, putting gas into the gas reservoir, right? That gas was originally petroleum pumped out of the ground. It went through a significant refining process, and then it was transported maybe by ship, maybe by truck, maybe by train until it finally gets to the final destination. And whenever you go from a large thing to a small means of transportation, we call it a break of bulk point. And if you think about this, guys, if you are the manufacturer at each stage of that transportation, you're having to pay something, right? You're having to pay a driver of a vehicle. You're having to pay for gas that's going to move that vehicle, that product to market. That's why gas prices affect everything, right? If you increase gas prices, mean every company has to pay more because basically everyone needs to transport something, right, from point A to point B. Okay, so transportation is an important consideration. And just as a side note, the evolution of shipping containers, which we call a containerization, yes, that is a word, has made the transportation of goods much more efficient over time as we've now standardized those containers. You can maximize space best with those containers. So that's a important breakthrough. All right, so to help us understand, to put all this together and come up with a model that geographers use, we're going to take a look at this next slide here. And this is called Weber's least cost theory. And I know it looks kind of funky, and it's going to consider really two things when figuring out where to locate a factory. It's going to consider distance from the inputs to the market, and it's going to consider weight. Now, both of those variables are of key importance when you're locating a factory. Now, obviously, there are other things. We just talked about 5 things. We're looking at 2. There are other things involved, but this is um, extremely important. So Alfred Weber was a German economist, and he created this theory in the earlier 20th century when Germany and really sort of the core countries were in that stage 3 of Rostow's model, that stage of rapid economic takeoff. And many of the products that were being produced and transported were really heavy, right? So we're talking about, you know, train cars full of coal. We're talking about iron ore. We're talking about, the final product, rolled steel, and everything else. So weight was an extremely important concept to this model. And so this is what he did. He took a couple of different inputs. So, does this concept relate today? Yes, sort of not. It's one of those things. A lot of the models that we learn only have a vague semblance to considerations today. So he said, okay, consider you've got 2 inputs and you've got a market. Now, where do you want to locate a factory? If you are considering distance and you are considering weight, well, it depends how much everything weighs here. So, for example, if input 2 is heavy and input 1 is lighter, and the final product is lighter, you're going to want to locate closest to the heaviest input, right? So, a great example would be, let's talk about iron and refining iron, right? So iron is pulled out of the ground in these massive chunks, right? And those chunks are not light. Now ask yourself, if you're the manufacturer, do you want to move that chunk all the way from point C to point A, then refine it, then sell the finished steel? No. You're going to want to refine that as close to input 2 as you possibly can by point C. And maybe there is another input that weighs considerably less. In that case, you want your factory to still be located closest to the heaviest inputs, whether it's input 2 or input 1. Now, here's the thing. While many products do lose weight as they're refined, we would call that, bulk losing. Some goods actually increase in weight when you produce them. And if that is the case, then you want the final product, which is heavier than the inputs, to be located as closely to the market as possible. And that in this diagram is near point A. So a great example of bulk gaining is anything you add water to, meaning bottling, right? So if you crack open an ice cold Coca-Cola from the machine, right? What are the ingredients of Coca-Cola? Water, sugar, and a lot of other things that are actually going to weigh less than the final product. I mean, obviously, you need to have empty cans too, right? Or bottles. And when things are empty and don't have water in them, they weigh less. So if you are a bottler, you don't want to produce the good around point B or point C and then transfer it all the way to point A where you're selling it in the market. You have to pay all these extra transport costs, the weight of those filled bottles, etc. What you want to do is you want to locate that bottling plant here at point A as close to your market as possible so you don't have to drive it very far and you don't have to pay somebody to do that kind of work. So we tend to see bulk gaining products, those that gain weight, close to the market, and bulk reducing products, those that lose weight near these exterior points. Now, what if you have a product that uses two inputs, and both of the inputs weigh kind of the same? Well, that's what point D is for, right? D is kind of the compromise anywhere inside of this triangle between input one and input two. Okay, both of these inputs weigh about the same, both are heavy. You're going to manufacture them at point D, and then the final lighter product is going to come here to point A. Okay, and so again, this is Weber's least cost theory. You need to know it. You need to kind of understand how this works. And next week, you guys are going to participate in an activity where I will give you some inputs, and you're going to have to determine a real place somewhere where you're going to build a factory. All right. So take a look at this, maybe draw a brief sketch of it, and I will see you guys on Monday. Take care and have a great weekend.